Today we have a panel for you on FHEvolution, and so we'll just have a brief introduction from each of you to describe who you are, kind of how you got into FHE, and what your company does. Oh, and just to start, my name is Ryan. I work at Sunscreen.
Hi everyone, I'm Gurgen from Privasea. So at Privasea we are working on building a FHE computer, and we would like to bring opportunity to bring privacy to Web 2 and Web 3 worlds simultaneously. And we're also working on building developers ecosystem because we believe that we need to simplify FHE development.
Everybody, Christian again. We met earlier. Good to see you.
Hello everybody, my name is David Jiao. I'm co-founder and CEO of Privasea. Privasea basically building the AI DP infrastructure, and on top of it we'll also provide a solution for proof of humanity.
Hey guys, my name is Elena. So I'm CEO, co-founder of Verisense. Verisense is a FHE-enabled validation as a service network, which can plug-play with any restaking layer, because we're very much committed to realize the true vision of restaking for shared security.
Awesome, thank you very much. So my first question is basically, what role does FHE play in each of your roadmaps?
So basically, FHE is more or less our fundamental infrastructure. We use that to building a DP network, which is on one hand we crowdsource computation power in the public network, and on the other hand we provide these computation resources to application runners. And so basically we have smart contract to control all of this, including the incentive mechanism, and also having onboarded applications. And we host it in decentralized nodes. With that, we provide our own official application, which is provide proof of human, and it's called Human app. So trying to building on top on this network by using decentralized FHE machine learning pipelines we have. So FHE for sure is very important, and the reason we can bring FHE to the public, which is we think the optimization is very important. We can so for the solution we have to do the proof of human, we basically bring down the FHE face recognition solution. From originally we have like 10-second delay, but now it's everything can be done in 1 second. So we can use that for proof of humanity by using human biometric data.
Any other plans on how to use FHE?
Yeah, maybe I can continue. For us, FHE is also a core technology because our network consists of FHE actors. Each of them can provide some FHE computation. It's heterogeneous actors. At the same time, with FHE we use ZK, we use NPC, but FHE still be the core technology in our system, in our platform.
Very cool.
Yeah, so I think the term business run around is confidential compute. And so a lot of us are using not just FHE, that's our core, but we also use ZK for the data lake product that I mentioned earlier. We use ZK for input output, and then FHE as well. And so we use, we consume services from Zama, CKKS, or different libraries. But ultimately, customers have different needs. So whether you need to use MPC for decryption at some point, or if you don't need decryption, it changes based on the kind of customer needs. So we optimize all that in-house with a blend of either FHE or MPC or ZK.
Nice.
All right, so as I mentioned, the Verisense is actually using FHE in the restaking. So I'm sure some of the audience here might think, all right, how does that work on restaking, right? Because when we're talking about restaking, most people think that restaking at the supply side, meaning that it's driving up the TVL and it's something like Eigenlayer, Karak, or Symbiotic are doing. However, I think right now it's a time to do the strategic shift from the supply side to the demand side. meaning there should be some infrastructure or platform to really onboard the ABS or decentralized security service or whatever term you're mentioning, right? Essentially, it is any the system or application that requires decentralized verification or decentralized kind of semantics. So in this case, Verisense is focused on the demand side, which means that we use FHE in multiple ways just to form the consensus for a smaller network, faster and secure. I want to mention this again, that when you try to form a consensus fast, easy. When you try to form a consensus secure, easy. However, when you try to do both, it's hard because those are two kind of conflicting requirements, right? You want a fast and you want a secure. So then we're thinking about that, we're focused on using some kind of a unique way to form the consensus fast and utilize FHE to enhance the security. So that's where, we're using the FHE at a network level. And then from top of that, because we're focused on onboarding all kinds of a decentralization application in the context of the restaking, that is ABS or DSS, right, depending on how you use this. Then we also are committed to using FHE to onboard some FHE implement or FHE enabled application, especially at the initialization stage, because we all know that FHE application requires to do some initialization in terms of the shared key, the security key sharing, right? So for that part, you could utilize a smaller network to quickly kind of finish this initialization and then swap it whenever you want it with very minimum cost. So the Verisense is able to provide this FHE implementation at the application level as well. So a quick summary: network level and application level. Yeah. So that's how we use FHE in the Verisense.
Great, thank you so much. So one of the questions we constantly get asked at Sunscreen is FHE practical today? So we heard a little bit about it at the keynote, but I'd be curious what the panel thinks about that.
Okay, let me start. I think the answer depends on what we mean under practical. For sure, I'm more than sure that FHE is practical today because we already have enough use cases where we proved that FHE can be used. Another thing, that there are enough use cases where we can't use right now FHE because of different reasons. Performance, complexity, but we see the progress in all fields around FHE, and we believe that it will be much, much more practical in coming years.
Great, thank you.
Yeah, so it's practical today, but we're not quite ready for an end-to-end encrypted web yet. So Kai actually mentioned earlier, there's two areas that are constantly improving, which are schemes and then hardware. So the chip makers like Cornami and Ontalysis, every time I talk with them, their prediction of when we hit 1000x scalability comes down like by 6 months. They keep peeling off 6 months every time I talk to them. And I think that gets back to this idea that even though founders in this space are typically bullish and sometimes we're more optimistic than we should be, it just seems to be true that our brains are good for linear thinking but not exponential thinking. What we're witnessing in hardware acceleration is definitely exponential growth. So I think it's very promising.
Yeah, that's very exciting.
Sure, yeah, thank you. I think, it depends on who we're asking for this question, right? Because I often got this question from VCs and some mainstream audience, just because this is still quite far away from normal people's use case, or the use case in their daily life, right? However, for technologists, entrepreneurs, or startups, we're, kind of tend to be more leaning towards to new technology, and I think, it's actually been developing really, really fast, faster than we ever thought. A couple of years ago, it's almost like, really, really hard to use. Now we have, a couple of companies like Zama has been pushing the whole technology one step further. And then, the bootstrapping time, has been drastically gone down. quite a lot. And so, given the same trend, let's just think about that. Same time same time next year, where it's going to be, right? I think it's going to be, developed quite a bit. So in this way, I would be very optimistic about that, and I would think it's quite practical. And especially, for Verisense use case, we are actually at the using FHE technology to implement blind voting, just to kind of add an extra layer of the security to the network for the consensus, security purpose. Then it's already very, very practical for us. But for certain use case, let's say that the high computation based use case, or that requires a hardware acceleration, it might be one step away. So really, my thought is it depends on who you ask this question. But again, I'm always very optimistic. Yeah.
Yeah, I think it's practical as long as you really focus on one niche use cases. But in general, I would say right now, if you look at the whole landscape of FHE applications, if you want to have a really general solutions to cover all scenarios in the long tail effect with all scenarios, it's kind of hard, to be honest. Actually, some of my teams in we were doing a benchmark for all the current hardware in market, and to test the functions in the TFHE side to see which one could be the best one in the current market with the best ROI as a hardware to cover most of the use cases. So we've been doing that. We're probably going to publish this article soon in a couple of weeks. So I think if we say practical, it definitely needs to be applied to the certain use cases and do a lot of optimization on this. That's my opinion.
Just more comments from my side when we talk about practicality. Recently, Apple announced that they added FHE inside iOS 18. So I think this is just one of the answers about practicality.
Do you know in what particular way Apple did that?
They used for some. There are not a lot of things about how they implemented, but as far as I know, they used for some stuff around recognition, some privacy recognition.
Nice.
Yeah, that's very exciting, especially very big company.
Well, I think that's important too to mention that if you've looked at their marketing recently, they're trying to separate themselves by saying private. They're private. Like if their Safari advertisements now, they're actually bringing Safari back, trying to compete with Google, probably because they smelled blood in the water with the antitrust stuff. And so interesting that they're launching that. I saw that news and I was like, this is really cool because they've started to bring back security and privacy into some of their wording, like public-facing marketing, and for them to also now release an FHE project goes hand in hand. I think it's really compelling for the space.
Yeah, definitely. It's super compelling. As a good follow-on question, what's the biggest obstacle to mass adoption to FHE today, and how do you think that we can address that for anyone on the panel?
Well, I'll let these guys speak to some other things. I'll bring up one point, which is regulation. I think FHE is really interesting. It's you're a little bit in the Wild West with regard to if a major conglomerate's developing it, great. Intel, Microsoft, Apple, awesome. They're going to be using it on to hopefully secure customer data, but on their side. But if you release FHE tools or services to the market, like you can do, especially in crypto and a decentralized where you can crowdsource FHE use, that's a lot of power in the hands of people to protect their own data potentially. And so there have been, there have been some, I guess you could say, like regulators became aware, I think, of the power. We saw some moves in the spring against some builders that were using FHE that seemed to be like a coordinated attack. So on the one hand, I think there's some regulatory issues that have to get cleared, and it's kind of a sensitive area. It's okay to talk about security, but when you start talking about privacy and privacy that users can obtain themselves to protect their data, now you're getting into like deep regulatory waters, and we have to be careful how we word that. So that's a little bit of a headwind, I think, in the short term.
Okay, go for it.
Yeah, I got this question last night and I thought about it, for a few minutes. I think there's Kristen mentioned good things, right? Regulation, and then there's a few other things. I think one is, of course, the hardware. Yeah, we mentioned that, right? We are calling for the hardware that was kind of accelerations and that is able to bear the high computations. For sure, right? But always, our history has proved that when it comes to hardware, it's always faster than you thought you get to, where you want, because it's always evolving really quickly. And the second thing I would say, we need more companies that works on those libraries or fundamental supplies. Besides Zama is doing good things, but we're calling for more companies. Especially like open source projects that co-building more libraries for us to use in order to really kind of see the applications kind of thriving. And the third thing I would be the knowledge or perception, because I'm sure like people talk about ZK, oh gosh, for a long time, right, in the Web3 history. But FHE seems like a new concept, recently uprising. But however, in terms of the technology origin itself, it's been like, as original as ZK, but people don't think that way, right? So from the knowledge spreading or the perception perspective, I think, people on this stage, we have a certain responsibility to really spread the word and promote this technology. So that could be another level of the obstacles that, FHE got really mainstream application.
The equivalent is like trying to explain CK snarks to somebody in 2019. That's what explaining FHE is today.
That's why we're asking the question, whether FHE is a practical. Nobody's asking the question whether ZK is a practical. They're equally practical or equally unpractical in a certain way, right?
Yeah, good point.
Yeah, I think it's two the main popular questions. Is it FHE practical, and when we will achieve mass adoption of FHE? I think I totally agree with guys mentioned. In addition, I would like to mention that we need to simplify FHE development. We need to bring opportunity to build FHE applications for developers. And you guys working on compiler, different guys building compiler, Google works on compiler. We also firm as working on developers ecosystem because it's a little bit different way to build FHE application because you always work with encrypted data and result also still encrypted. It's not the same as when you work with open data. And it's not too easy to build compilers that will translate algorithms or programs that works on open data to FHE. At the same time, I believe that we just need to show at least one real world popular use case which will work, and we will have mass adoption immediately. And I believe we also will achieve it soon.
Yeah, that's exciting. David, do you have any comments?
I think I totally agree with all the guys here. Definitely we need a mass adopted application come out first to make sure public really feels the ease of use of FHE and the benefits they can get to preserve their privacy side. I mean, this is very important because I feels like even the GK users, they really don't care what it's actually using it for. I mean, it's that doesn't care what technology behind it. For them, it's like they need better services, right? They need application really protect their privacy. That's all.
Another small thing: do we really need mass adoption? Do we need to integrate FHE in everything, everywhere? I don't think so. I think that we need to be very careful around where we really need to integrate FHE, because it's really not needed to bring FHE in all use cases. Because in some use cases, you can just play with not fully homomorphic encryption. It's maybe more than enough to use just end-to-end encryption. without FHE, just some regular schemes.
AES 256 is almost
Yeah.
quantum resistant, right? It's close enough.
Thank you for the responses. So my next question is, patents have long been controversial in the cryptography community. So what role should patents play at FHE, and how might patents affect how the space evolves?
Okay, I can start. I think it's a very important question. For sure, every company wants to claim the patent and prohibit in-house technology. But the important thing here is that if we talk about the FHE, if we talk about our area, we need to be careful around it, just to not slow innovations and development of FHE. And also, as Wang said, that it's really difficult to claim of the ownership of mass, because all of FHE based on mass. And
Unless you're a government.
yes. But yeah, it's very, very important and very, very sensitive topic.
Any other opinions from the panel?
Well, so for me, I feel like, just because right now we're in Token2049, I believe most of the focus are Web3 related, right? So we naturally think that, FHE plus Web3, which would be more like, the liberal side, right? Which means, probably more against the idea of like, patent up and then issue, lots of money from, try to charge lots of money from that. But at the same time, FHE is also, has a broad application to very different industries, right? Healthcare, right? Compliance, something else, right? Which will be very different view from those industries. So that's really just like a yes and no, and then depending on the real use case and the industry we're talking about. Yeah. So I don't think that there's a clear answer or like a yes and no answer towards this question. We need to really like think broad.
I think the game is kind of shifted though. So what you're going for today, especially for the project, is network effects. And the ability to bring a product to market is so much faster than it was historically. And there's a key problem that was being solved. Crypto came around at this perfect time. This is a real generality, but you saw private companies taking longer to go public in the early 2000s. They were slowing down. There wasn't a rush anymore. It's like, why would we go public? Now we're accountable to shareholders. We're going to invite all this regulation and all of this, enforcement action. So let's just stay private. We'll stay in our sandbox and get some IP. But now the fact that you can launch a token, you can monetize, you can build a treasury quickly, kind of solve that problem. So there's less of a need to build up so much IP. If you can get to market, you can get network effects, build a loyal following. That's, you'll have a moat. That's the best way, I think, to establish your moat, if you're launching a token at least. So it's kind of a way around the patent, and like Gurgen was saying, it's hard to patent math, unless you're a government, or to block any of that off, so we're all building in open source environments. So I think patents are less, from my perspective, less reasonable or practical, at least for Web3 today.
I totally agree. In Web3, it's very difficult to claim it.
Yeah, that makes a lot of sense. David, does the...
Probably I want to make some amendment on the previous question about the mass adoption thing. I still have something I want to bring. And then I really agree. I mean, FHE needs to bring usability, that's for sure. But mass adoption is also quite important, especially for in our tribe, FHE here. I mean, if you look at the few years back for the DK, they do have a very, at least in Web3, they have these roll-ups come up for all their tools. That's one of the mass adopted use cases, which brings them money, bring venture capitals into this domain, and also bring attentions to it. And right now, I feel like FHE is still lack of attention compared to a lot of other crypto spaces. I mean, we need that. We need something to come out. That's my opinion.
Yeah, that makes a lot of sense. So I have a question now for each of you specifically. So, Gurgen, what are the advantages of a collaborative approach to building out an FHE EVM?
It's a good question, and with our collaborative approach, we are working on solving one of the main challenges in open source in general, because as we can see, developers doesn't have motivation to contribute to open source project they're not related to, and we can just see that in any repository, open source repository, we have some limited numbers of contributors, mostly from the owning organizations. Just because, in my opinion, in most cases, developers doesn't have motivation to do it. And with our collaborative approach, the main idea behind it is to provide incentives and motivation to developers to contribute and work with us. Because the idea that in our ecosystem, if you are a developer, and you're not business guy, you're just developer, you're strong guy, you know how to build some FHE circuits, FHE function, but function by itself in most cases doesn't have a monetization model. And in our collaborative approach, how it works, you can bring just small component you develop, it may be some function, it may be some circuit, and you can monetize it, so it will provide your incentives. Another thing with collaborative approach, we also utilize competition-based model, which accelerate innovations, we believe. And this is ideas behind our approach.
Nice, thank you. Christian, what role do you see FHE play in AI?
In AI? Well, so obviously, where we think it's really effective and really compelling is this minor validator relationship that I talked about in the opening speech. So there's, we look at AI and we see this incredible, when I look at this crypto AI sector, it's an incredible opportunity. There's all of this governance that's needed. We actually want people throwing voting power and governance into AI networks because the models need it. This is a whole, some crypto AI builders don't think that crypto AI is competing with centralized AI. I disagree. I do think the sector's going to blow up. I think, you've got companies throwing hundreds of billions of dollars in development, so there's enough for everybody in a sense. But at the same time, someone that's using a BitTensor model, there's an LLM, one of the subnets is an LLM. If you're using that, it's less time that you're using ChatGPT. So if you really get down to the minutia, I think there is obviously competition, and I think the key metric, or one of the key metrics, if not the key metric for crypto and decentralized AI to succeed is going to be model reliability and how effective they are. Are they useful? Are they doing things that people actually need? And Eric Schmidt was just talking a couple of weeks ago at Stanford and was saying that probably by the end of next year we're going to have something like the first iteration of true agentic workflows where a user will be able to interact with an agent that can go off and compute or take care of a number of different tasks and then come back with the answer. Like, that's coming really, really quickly. And I think that's exciting because we're all going to have our own personalized assistant in the very near future. So I think decentralized AI models can compete. They can move faster, but they have to be reliable. And so right now they're not super reliable because they're getting ranked by the people making the model in a lot of cases. So it's state for consensus. Let's start protecting data inputs. Data is the new oil, especially in AI, and there's just hordes and hordes of data being fed into these models for training. We don't get to see biases in the training data. None of us knowingly signed a waiver to release all of our data to train these things. We're not getting checks because our data was used, and that's not the model. That's never going to work in centralized AI, but that is the way it can work in decentralized AI, right? You can actually get paid for contributing your data or for helping to refine the model, for making models. Overall, I think the future looks a lot brighter. We've got decentralized AI models eating share from centralized AI models. But the key metric there again is model reliability and creating a shared private state with consensus, I think, is key.
Yeah, that's a very interesting point. So David, what made you decide to use FHE for privacy in your network over trusted execution environments for NPC?
Oh, that's a really good question. We do consider like in the beginning, and the reason we choose to use FHE, one of the most important reason is that, I mean, there's quite obviously several other reasons, but the most important one is because we are dealing with biometric data right now. So biometric data is very important, very sensitive, and needs to be compliant in a lot of regions, and especially in the public network, if you want to permanently store the biometric data, you need have a really competitive way to do that. I mean, compare, for example, TEE, it probably you can. It's good on the performance side when you compute it on it, but you need to somehow decrypt it, rely on some hardware like IntelliJ, and then eventually when you share the result, you need to have several other ways to do that, probably a PC involved. And for us, FHE can solve it perfectly. Everything for the user, individual users, biometric data goes into our network is permanently encrypted and decentralizedly, and can be computed on decentralized nodes, which is in our network. And the result, the biometric comparison result can be shared directly in our network with the function via app, which is we using sort of like an MPC wallet scheme. So basically, we have chopped this FHE key to 3 channels. One in user phone, one in the user's backup drive, another one is in our server. 2/3 can decrypt the biometric data. So the solution here we have here is one very straightforward and is I would say fundamental words for this very sensitive biometric data. That is the key difference between our solution and the FHECon. Yeah.
Thank you very much. Elena, what role does FHE play in restaking and allocation?
Yeah, sure. So I think I get into this details or concept a little bit when I just introduced myself for the first question, right? Again, I want to emphasize, when we're talking about restaking is not driving up, it's not just for driving up the TVL. I'm sure, like, some of you guys in this room might think restaking possibly is another name, for the fancy DeFi planes, right? It's just kind of another way to add up on this Russian doll type of techniques, right? You try to extract more money, no. So restaking is only just means. Restaking's goal is for shared security, and shared security is the key of blockchain. So you may be wondering, are we already doing shared security for blockchain, right? All kinds of nodes, join the network permissionlessly and all together working as a public ledger. Yeah, sure. However, restaking for shared security gives another way that allow us to break the limitation of the general purpose L1 blockchain, which is often in a few ways that having limitation. One is that it's quite passive. It's not able to initiate the data I/O and then actively access the database, which means that you're not able to immediately or frequently run the data queries, right? Without this, that means it's very hard for us to onboard the larger scale Web 2 application meeting decentralization requirements. So we all know that. That's the problem of general purpose L1. Blockchain can only do what a blockchain is doing. So then how do we do that? So then Eigenlayer came up with this amazing idea of restaking. But again, as I mentioned, at this moment, we're very much focused on driving up the TVL, which is the supply side of the security. What is the method of the demand side of shared security, which is really onboard some applications that are actually using those kind of methods and paying for the validation. We didn't know that, and Verisense is committed to do that. And one way is to do that is we find a very fast way to form the consensus on a smaller network and only, request the developers or whoever using the validation as a service concept pay for what they really need. So meaning a small project, like individual developers can use this concept to form a small network. But then people would argue small network has a less security. How are you going to do that, right? And we use FHE to invent the blind molding. And you may ask why blind molding is needed. Think about that. Let's say that we use a token ring protocol, meaning that we have 5 nodes to form a network, and each one of the participating nodes can only do something when this node gets token. For example, this node gets a token, then is allowed to finalize the transaction. So each node votes sequentially. That means without FHE, people knows each node knows the previous votes. Then that leaves a bribery room. How do we resolve that? FHE. It's a perfect solution for that. So I think there's a multiple way that we can think about how we could use FHE to enhance the network to resolve some fundamental problem of blockchain. Yeah. I hope I got this clear. But if you guys have any question, feel free to come to me. And then at the same time, that Verisense is hosting an event on this Friday, FHE Day at Singapore, and we're gonna have a couple other projects there. Having a dedicated session to explain their projects. So yeah, that's what I want to share.
Awesome, thank you so much. And I just have one final question. We have only approximately a minute to answer it, but it's how do you think FHE is going to evolve in the next 5 years? And maybe more specifically, what applications are you most excited about 5 years from now?
Because myself, worked for Polkadot for many years, which is a large, general purpose L1, right? So we do realize that there's some problem over general purpose L1, and we're thinking about that, how we can break the limitation of a blockchain and really able to provide a whole nest of infrastructure for large-scale Web2 application, meeting the true purpose of decentralization. So imagine the decentralized TikTok, decentralized YouTube, true decentralized email, forum, Notion. That's something that I'm looking forward in the next few years. Yeah.
Awesome, thank you so much.
As I actually asked Ran the same question a few weeks ago. I think that LLM is definitely the most what I expected if FHE can be applied to large language model. And if the FHE the hardware acceleration and the fundamental library can improve in 5 years, it's definitely